Okay, let's make a truth table for the formula P, not the quantity P and Q in quantity. This is part of this, how you do problem number 28 in section 1.1 on page 13. So to do the truth table, we need to make up a table, and the starting is going to be the two variables P and Q. They each have their own column. And then, since there's two variables, we need to have 4 rows. That will allow for all the possibilities of the truth values for those two variables. And the entries are true, 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 false, false, true, and false, false. Notice the pattern in the Q column is alternating T's and F's. In the P column, there's 2 T's and 2 F's. Now, if we had 3 variables, we'd have 8 rows, and the third one over here would have 4 T's in a row, then 4 F's in a row. So, but let's get back to here. We want to work from the inside out. So we want to do P and Q first. And remember, for an and, the only way for an and to be true is they both must be true. So the first row is true and the other 3 rows are false. Now when we finish up and do the not of that, all we have to look at is this column here. So we can ignore the first 2 columns and look at the third column, and the negation sign says to flip the true false values, switch them. So T goes to false, false goes to true, false goes to true, and false goes to true. And you'll notice in this last column here, it's the same entries as for the NAND connective in problem number 28. So thus, this formula up here is logically equivalent to the NAND connective.